of B Pharmacy syllabus, second year. I have prepared this summary. This is reaction, and it is a type of reaction, which type of reaction it is. Then it's a starting compound, intermediate, catalyst, and the product of this reaction. Now, if you see the first reaction, it's a pinacolon rearrangement. It's a rearrangement type of reaction, and for this we required starting compound pinacol. It means bicinal diol. Intermediate form is carbocation. Actually, two carbocations are formed. The catalyst for this reaction is acid, like H2SO4, and the product form is ketone. So we are taking diol alcohol, and we are converting this alcohol into this ketone. So this is called pinacolon rearrangement. The next one is Hofmann. This is also rearrangement, and in this the starting compound is amide. This amide converts into primary amine, and intermediate is isocyanate. The catalyst for this reaction we have to use is sodium hydroxide. Baeyer-Williger oxidation, it's an oxidation type of reaction. The starting compound is ketone, and the intermediate is Krige intermediate. For this we required catalyst peracids or peroxides, and the product form is ester or lactone, cyclic ester. Next one is benzylic acid rearrangement. It is a rearrangement. The starting compound is benzyl, and intermediate is benzylic anion. For this we required catalyst strong base like potassium hydroxide, sodium hydroxide, and the product form is benzylic acid. It is simple, benzyl to benzylic acid, and the name is benzylic acid rearrangement. The next one is Beckmann rearrangement. It's a rearrangement type of reaction. The starting compound required is ketoxime, and the intermediate is nitrylium ion. Catalyst used for this reaction is acid like H2SO4, and the product form is amide. Next one is Schmidt rearrangement. It's a rearrangement where we have to take starting compound ketone or aldehyde and hydrozoic acid. This is something different, this ketone or aldehyde plus hydrozoic acid. Intermediate form is azyl intermediate. The catalyst here also required acid catalyst like H2SO4, and the product forms are amine if we are using ketone, amide if we are using aldehyde. The next one is Claisen rearrangement. Claisen-Schmidt condensation. This is a condensation type of reaction, and the starting compound we have to use is aldehyde and ketone. Intermediate form is beta hydroxy ketone. Base is the catalyst, and the final product is alpha beta unsaturated ketone. The next one is Clemmensen reduction. It's a reduction. Starting compound is ketone or aldehyde. The intermediate is not very clear. The catalyst used is zinc amalgamation and acid HCl. For this, the product form is saturated compound alkane. So ketone or aldehyde converts to alkane. Next one is Wolff rearrangement. It's a rearrangement. Alpha diazoketone is the starting compound. The intermediate is carbene, and this reaction happens in case of heat or light or Ag2O. The final product form is ketene, and from the ketene, this carboxylic acid or its derivatives can be formed. Next one is Oppenauer oxidation. Oxidation, it is secondary alcohol we have to use. The six-member transition state is intermediate state, and for this characteristic catalyst aluminum isopropoxide is used. The product form is ketone. We are taking alcohol, secondary alcohol, and the product form is ketone. This next reaction is Deakin reaction. Deakin reaction, it is oxidation reaction, and for this the starting compound is ortho or para hydroxybenzaldehyde. The intermediate form is tetrahedral intermediate, and catalyst used is sodium hydroxide, potassium hydroxide, and peroxide. The product form is phenol and carboxylic acid. The last one is Birch reduction. It's a reduction, and the starting compound is aromatic, different compounds, aromatic rings. The intermediate is a radical anion, and for this catalyst we have to use is lithium or sodium in liquid ammonia. The final product form is 1,4-cyclohexadiene. So these are the useful reactions, and this is the summary table. Now this summary table is useful to remember these all reactions, and we can compare this to these reactions also. So this is summary of reactions.